Hello everybody and welcome to your first astronomy lesson. So yesterday we did our intro to earth science, which was just a general overview of the branches of earth science. Well, today we're going to jump into our unit 1, which is on astronomy, which is something that you guys should have learned a little bit about yesterday, since astronomy is one of the branches of earth science. So let's go ahead and get started by talking about Earth's position in space and how it falls within the hierarchy of the universe. So this says, did you complete your vocab? I hope so. I hope that you at least started your vocabulary. I know it's probably not done today, but a lot of the words and the terms that you're going to see in today's lesson are also in your vocabulary. So I hope that you guys are still working on that. Remember, it'll be a part of your notebook check that I will check right before your Unit 1 test, but you should be working on that to make sure that you've got it all done and that you're more aware kind of the terms that we're going over as we dive into this lesson. Okay, so you guys do have this in your interactive notebook. This is a pyramid that shows the hierarchy of the universe. So you guys should be able to click in that green pyramid in each section and type in the words that you see on the screen here. So this is organized from largest to smallest, with the largest being on the bottom of the pyramid and the smallest being on the top. So what we see here, this is called, again, the hierarchy of the universe. Basically, you can look at each section and wherever it is, whatever's on top of it basically is included in that thing. So on the very bottom, we've got our universe, which is of course the largest. And the universe includes galaxies. And then those galaxies include star clusters. The star clusters include solar systems. Solar systems include stars. Stars will include our planets and our moons. And then asteroids, meteors, meteorites, and comets are at the top, are the smallest, okay? So all of these things can be found in our universe. Universe, again, is the largest, and then our asteroids, meteorites, comets at the top are going to be our smallest. So let's talk about Earth and Earth's position in the universe. So our planet Earth is our home, it's where we live, and in our solar system, so a solar system includes a major star and the planets and the moons that revolve around it. So our solar system, we are the third planet from the sun. That means there's 2 planets between us and our sun. Within our solar system is within the Milky Way galaxy. So our galaxy is called the Milky Way. And we're located in something called the Orion arm within that galaxy. Our local group has about 40 galaxies, so we're part of a cluster of 40 galaxies. So if we think about it, it's kind of mind-blowing to think about how large space is, because we exist in our one galaxy, and our galaxy is big, but we're not the only galaxy. There are at least 39 other galaxies around us, and then billions of other galaxies in space. So it's kind of crazy to think about how much is actually out there and how much we can't even see because we don't have the technology to see it. Our supercluster is called Virgo. Don't know if there's any Virgo star signs out there, but we are in the Virgo supercluster. And then that supercluster is located in our universe, which encompasses our galaxy and all of the other galaxies. So let's talk about Earth's motion through space and how it's related to the origin of the galaxy and its solar system. So in order to talk about what's happening with the expansion of space, we have to talk about the Big Bang Theory. Now, the Big Bang Theory is kind of just the theory on the origin of really everything. So in the beginning, scientists believed there was nothing. So there was no time and there was no space before the Big Bang. But what happened was, basically the universe began as a single point and has been expanding ever since. So we call it a Big Bang And some scientists refer to it as an explosion, but it really wasn't an explosion. It was more like an expansion. But think about if you're watching like a TV show, like an action movie where there is an explosion, it starts at a single point and then it gets larger and expands out and out and out into a big cloud of fire and gas, right? Well, our universe kind of did the same thing. So if we look here, we've got the point of origin. It's in one singular place. And then after this expansion, our universe just kept expanding. And eventually we got the creation of galaxies and star clusters and planets. And it's still moving too. So it says, notice how the galaxies in each successive picture are moving apart from the singularity. So it means that basically every day we're moving further and further away from the origin of the universe. We're moving further away from the point where the universe began. You guys know that the Earth spins on its axis and we revolve around the sun, right? They teach you that like in elementary school. So what a lot of people don't realize though is that it's not just the planet that's moving. Our entire galaxy is moving. Our whole Milky Way galaxy is moving through space. And as time goes on, we are moving further and further away from where the Big Bang started. Scientists even believe that one day our universe is going to run into another one, or not our universe, but our galaxy is going to run into another galaxy called the Andromeda Galaxy. But that won't happen for a really long time. We won't be alive when it happens. So here's just a depiction of the Big Bang Theory. There's a lot of technical terms in here that you do not have to know. So it does talk about protons, neutrons, atoms. I just need you guys to have kind of a general understanding of the timeline, so how long it took, and just in general what was happening at each point. So step 1, time begins. We have our Big Bang or our big expansion. And basically there was a super fast inflation. And the universe kind of goes from the size of an atom, which is super tiny. It's the smallest component of matter. Okay, so it goes from the size of an atom to a grapefruit in a fraction of a second. This takes no time at all. Okay, so then the universe is super hot, and it's just kind of a soup of the particles that will eventually form matter. Okay. And then in step 3, after the universe being super hot, there's a rapid cooling that allows these particles to kind of clump together to form the precursor to atoms, okay? And all of that, the inflation, the heating, the cooling, happens in 1 second. 1 second. That's all it takes. Okay, so the first 3 steps were really quick. But then, after a few minutes, it's still too hot to form actual atoms, but we're getting there, okay? There's kind of like this super hot fog in the universe. And then finally, after about 300,000 years, we finally get electrons combining with protons and neutrons to form atoms. And atoms are the building block of matter, okay? It's going to take 1 billion years for gravity to make hydrogen and helium coalesce to form the giant clouds that will eventually become the galaxies. So the first part of the Big Bang takes no time at all, just 1 second, but then the formation of the actual galaxies that we see takes a long time. And then finally, 15 billion years. A billion is a long time, but 15 billion years later, we finally have our galaxies, our planets, our solar systems as we know it. And here we are at present day as humans on our planet. So there's 15 billion years between us and the beginning of time. Our Milky Way galaxy, so astronomers think that the galaxy began as a rotating spherical cloud in space. So think about that last step in your Big Bang Theory. So basically, our Milky Way originated from all of this dust and debris kind of coming into this rotating spherical cloud, okay? And then our solar system continues to orbit the center of the Milky Way, because it developed in the plane of the disk that orbited the central nuclear bulge of stars. What does that even mean? Basically, the nuclear bulge is the center of the galaxy. Okay. And our solar system, when we say our solar system, so our solar system is within our galaxy, it continues to orbit the center because it developed near the center. Okay, just kind of like our sun, we orbit around our sun because it's kind of like the central part. We also orbit around the Milky Way because it developed from that nuclear bulge. So this depiction right here is on like kind of like a top view, and then this is what it would look like on its side. So the nuclear bulge is really just the center, and then we've got this debris all circling around it. And then here's our Milky Way. Remember, here's Orion's arm. This is where we're located. Okay, and then here's the sun. So we are located in this particular spot near the nuclear bulge of our galaxy. And here's an image of our galaxy, the Milky Way. It's actually really pretty. All of these stars are a part of our galaxy, which is then in turn a part of our universe. This is a diagram of the formation of the Milky Way. What I really want you to take away from this is that basically gas and dust came together, started swirling in a circular motion, flattened down into a disk, and then we get our form, basically the shape of the galaxies that we know today. We know that our galaxy is a swirling kind of disk, almost like an oval shape. But I don't want you guys to get too hung up on the verbiage here. Our solar system, so our solar system consisting of our sun and the planets that we know, grow up learning about, began when a rotating interstellar cloud of gases called a nebula collapsed. And this collapse was due to gravity, and it did form the sun and the orbiting planets, which is us, right? So Earth and all the other planets. And then Earth orbits the sun because it was located outside the center of the spinning nebula. Okay. This is an image of an Eagle Nebula. It looks pretty cool. I think they call it the Eagle Nebula. I guess they assume it looks like an eagle. I don't know. I don't know if I see an eagle. Do you guys see an eagle? Anyway, a solar nebula is a disk of dust and gas, mostly hydrogen and helium. That's the elements you find most of in space. That can form a star and planets. So our star and planets came from a nebula, and then this Eagle Nebula one day might also become a solar system of stars and planets. And it says to draw this. You guys don't have to draw this. I just wanted to give you another diagram and a view of how solar systems actually originate. So in the earliest stages of the formation of a solar system, there's really just these swirling, rotating clouds of gas and dust. Okay, so this would be a top view, and then this would be the side view. And then that rotating cloud will eventually flatten out as it contracts. So it starts out kind of as more circular, and then it flattens out into a dish shape. And then the sun will form in the center, and then the planets form within the flattened cloud, and then those planets will start to rotate around the sun. Okay, so it's a very like cyclical process. Okay. We are going to talk more about the Big Bang Theory tomorrow as well. But this is just kind of like your intro to astronomy. And it's a lot to think about because our universe is very big. So that's it for your notes for today. You guys are going to complete your Big Bang Theory timeline in your interactive notebook. And I should show you directions for that in class. So if you have any questions, let me know. And then, of course, your notes and this video will be there for you if you ever want to rewatch it or have any questions. I will see you guys in class.